Morning, everybody. Today we're going to find another couple ways to prove triangles are similar. We're going to be using side, 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 and we're going to be using side, angle, side. These two should look familiar. There's a little more work to do than normal. All right, let's dive in. So the side, side, side similarity theorem says that if all three corresponding side lengths of a triangle are in the same ratio, they're all proportional, then the triangles are going to be similar. So we can find those scale factors to be all the same. We know the triangles are similar. So we look at this example. We want to know if DEF or GHJ is similar to triangle ABC. So we're going to compare this to ABC, this to ABC. Hopefully you get all the same things. They've done us quite a favor by color coding the sides, but we could figure it out by the order of the letters here. So let's get cracking. Alright, so we have AB. Well, AB is going to match to DE here. So we'll do 8 over 6, and that simplifies to 4/3. So I need to get 4/3 for all my other answers to get this to be similar. Alright, let's try blue. 16 to 12. 16 over 12. We divide by 4. We also get 4/3. This is a pretty good sign. Alright, let's try green. BC to FE. So that would be 12 over 9. And we divide both of them by 4. No, I'm sorry, by 3. And we also get 4/3. So we can definitely say DEF, triangle DEF is similar to triangle ABC. Let's see if this triangle is also similar. So let's start with green. Do 12 over 10. And that simplifies, divided by 2 to 6/5. So I need 6/5 for my other answers. Let's do red. Ew, 8 to 8. I don't think that's going to work. 8 over 8 simplifies to 1. Since these are not the same, we would say these are not similar. Alright, that wasn't so bad. Let's move on. So now I'm going to prove this. This is a rather clever proof. So if we go back to the side, side, side similarity statement, our if is that the ratios in proportion, our then is that the triangles are similar. So this is our given, this is our proof. So we're given that the sides of RS over JK is proportional to ST over KL is proportional to TR over LJ. Alright, so what we're going to do is we're going to find a point on SR, point P, that's going to make PS congruent to JK, or equal in length. Then we're going to draw a line parallel to the base here. Alright, and the parallel gives us quite a good option because we know that we have the angle for corresponding angles and the same reflexive angle. So we can prove that this big triangle and the smaller triangle are similar by angle. Given the fact that we already have the sides of proportion and that PS and JK are equal in length, we can easily deduce that SQ is equal to KL and QP is equal to LJ just by substitution. So, by the side, side, side congruence theorem, we know that triangle PSQ and triangle JKL are congruent. Now, since the triangles are congruent, and these two triangles are similar, we can use CP/CTC to say this angle and this angle are congruent, this angle are congruent, go transitive, and conclude that triangle RST is similar to triangle JKL. Alright, let's put it into use. Let's use it. So we want to find the value of x that makes this true. So we have ABC to DEF. And what we're looking to find here is whenever I do a proportion like this, I'm always looking to find sides that match up without variables. And I see that AB and DE match up. So I can say 4 over 12. And now I can solve for x. I can set up either one of these to see if it works. I'm going to do x minus 1 over 18. Alright, now I got to simplify. So I'm going to make this into 1/3. And we'll cross multiply. 1 times 18 is 18. 3 times x minus 1, remember, you have to distribute that. So we get 18 equals 3x minus 3. We add 3 to both sides. We get 3x equals 21, and quite easily x equals 7. We can check this, right? 7 minus 1 would make this 6. And 7 plus 1 is 8 times 3 is 24. Oop. Is 24. And 8 times 3 is 24. 4 times 3 is 12. 6 times 3 is 18. So it makes sense. All right. Here are a few problems. Why don't you give them a go, and I'll be right back. All right. So when we're trying to match up triangles like this, and we don't really have any similarity statements at all, we got to make sure just to match the shortest side with the shortest side, the middle side with the middle side, the longest side with the longest side. We do that for all of them. When we do these two triangles, we're going to find out they don't work out together. But when we do LMN and XYZ, we're going to find out that all three sides have ratios of 2/3. So this triangle and this triangle are going to be similar. Now part 2, it says the shortest side of triangle RST, shortest side of a triangle similar to RST is 12 units long. So we know that we can do 24, 12 to 24, and we get that ratio is 1/2. So without even seeing the triangle, we know the ratio is 1/2. So we just divide these two by 2. 1/2 of 30 is 15. 1/2 of 33 is 16.5. Hopefully you got that. So now here's our third way to show that triangles are similar. It's the side angle side similarity theorem. So this is just like we did side angle side for congruent triangles. We have to have two sides in ratio, and the included angle, in this case x and m, must be congruent. All right, that proof's going to be left up to you guys. So here's a kind of bizarre situation where someone's building a lean-to shelter, and they want to make sure that the triangles are similar. I don't know. I don't think this is part of any survival manuals, but we'll take it for what it is. Point is, are these similar? Well, we know we have this included angle, 53 and 53. That's pretty easy. We just got to see if 6 and 9, 10 and 15 work out to the same reduced ratio. So let's see. 6 over 9 reduces to 2/3. Okay. 10 over 15 we divide by 5, and this also reduces to 2/3. So we'll give this shelter a big whopping yes, it's similar. All right. Here's 2 more for you to work on. Give the video a pause through, and I'll be right back. So we're trying to prove the triangles are similar. We have this angle, so we're hoping side angle side, and the right angle are congruent, so that helps us out. So we do 24 to 18, that reduces to 4/3. 28 over 21 also reduces to 4/3, so we can use side angle side to show that the triangles are similar. In number 4, we can do this a couple ways, but what I want to make sure is I rotate triangle YZX to be in a kind of corresponding position to XZW. So I kind of tilted it down that way. So now when we do XZ is 12, that matches with 9, reduced to 4/3. WZ matches to XC, 16 over 12 is 4/3. And WX over XY, 20 to 15 is 4/3. So we prove this is similar by side similarity theorem. All right. So now we do a couple proofs. Just kind of try to follow along. I don't need you to be able to recreate these, but you should understand them. So anyway, the 3 ways we have to prove triangles are similar is angle, side, and side angle side. So depending on what information you can glean from the picture or the given, we'll kind of direct you as to which one you want to use. So now we're going to, we talked before about like we prove slope, right? We want to prove that parallel lines have the same slope. And there's a couple of different pieces, so you got to prove both parts. You want to prove that if lines are parallel, then they have the same slope. And you want to prove if lines have the same slope, then they're parallel. You want to make this biconditional. So what we're going to do here is we have line L and line N, and they're non-vertical. We want to prove their slopes are the same. So in the case that line L and N are horizontal, it's pretty easy because horizontal lines are parallel, all have the same slope. So it's true regardless without really any work. It's these non-horizontal, non-vertical, these diagonal lines, I guess, that make it a little harder. So what we're going to do is we're going to draw vertical lines from some point on there to the x-axis. And these lines are going to be parallel because they're vertical. And what we'll do here, we take the x-intercepts of both of them and connect them to the same point. So essentially what we've done is we have parallel lines, we have the x-axis as our transversal, and from there we know that we have the right angles are congruent. We have these two corresponding angles are congruent. So we use angle to show that triangle ABC, triangle DEF are similar. From there, what we're going to do is we're going to write a proportion. BC over EF equals AC over DF. And we learned our proportion rules where we can switch these two parts. So we can say BC over AC equals EF over DF. Now actually, BC over AC, that's rise over run. So that's the slope of line L. EF over DF, that's also rise over run. So that's the slope of MN, the slope of N. Now we can set these two equal to each other and do a substitution and a transitive and show that the slopes are the same. Okay, that's what we want to prove. Awesome. All right, one more. So now we want to prove the slopes of perpendicular lines theorem. So perpendicular lines, if the lines are perpendicular, then the product of their slopes is -1. And to make it a biconditional, if the slopes multiply to -1, then the lines are perpendicular. So we're going to prove part of it. This one's a little more tricky. So we have line L and line N that are not vertical, and they are perpendicular. We're going to prove that the slopes multiplies to -1. So what we're going to do is we're going to draw a horizontal line through the point of intersection, and then another horizontal line somewhere below that. Our horizontal lines are going to be parallel. Then we're going to draw a vertical line from the point of intersection straight down, and from some point on line L straight down. So we have vertical lines and horizontal lines. This gives us a right angle here and a right angle here, and that's going to be quite useful. So from here, what we're going to do is we know that angle CAE is 90 degrees because it's a right angle, because it's perpendicular. We use an angle addition postulate to say that this angle plus this angle is 90. Then do a substitution to show that since these add up to that equals 90. Given that, we know that angle BCA and angle CAD are congruent because they're alternate interior angles. That means their measures are equal. From here, it's a little bit of arithmetic. All right, we're going to do a substitution in from the above. We're going to substitute in BCA. And now we're just going to rewrite it as angle DA equals 90 minus BCA. And then use a triangle sum theorem to say that BCA plus 90 is 180, based on what we have up here. We're going to rearrange this to say that BAC equals 90 minus BCA. And now we have 90 minus BCA twice. So we're going to set these two equal to each other, which means they're congruent. And since we have angle ABC and angle ADE, ABC and ADE, so now we have this angle and this angle are congruent, and the right angles are congruent. So we have angle-angle similarity. From there, just like we did before, we set a ratio of corresponding sides, we rewrite our proportion, and when we do it this time, we find the slope differently. All right, rise over run. And now we multiply these. This doesn't look like we can do anything, but we do substitution, and we get DE over AD times negative AD over DE. These cross out, these cross off. The slope multiplies to -1. All right, hope you can follow that. If you look in your textbook and take your time and have the pictures side by side, it's a little bit easier. We'll go over this in class. I'll see you then. All right, bye-bye.